morning. This is the class ECE451, the control engineering. Welcome. Today we will do a review for the whole semester for the final exams. Okay, actually this is a 14th week. Wednesday's class. Okay, ECE451. It's a review for final. Review for final. So for the exam, it will be in the final week. 451. It's a Tuesday, right? Tuesday. So it is a Tuesday, 10:30 to 12:30. We have 2 hours. And similar with the midterms, we have 30 more minutes to prepare your work and to upload to the Blackboard. All right. So this is the time of the exam. Tuesday, actually, that will be December. Okay, the final week will be. Final week is December 7 to 7, 8, 9, 10, 11, 11. So 8. Yeah, December 8. Okay, December 8 exam. And then the office hour. Office hours. Actually, the normal office hour we have one in the Monday 4 to 5 p.m. This is normal one, and then in the 15th week, we have 2 more extra time, just the lecture time. The Monday and the Wednesday, every 9:30 to 10:45. Yeah. Alright. Yeah, so I use these 2 classes and this one as like office hour. If you have any question, we can discuss there. That being a Zoom meeting. You go to Blackboard, you go to our class, then in the tools you can find the Zoom meeting. Right. Okay. And the exam, we have 2 hours time, and we will have 6 problems, and cover the whole semester. All right. Whole semester. Same. I suggest you have a formula sheet. The exam is totally open. You can open book, open notes, even open your internet. You can use computer, use MATLAB. Yeah, but a formula sheet must be a helpful tool. You write down all the things you think they are necessary in a formula sheet, and that will save you time during your exam. Okay. What else I want to give? Okay, in generally just like this. If you have any question, you can ask me during these office hours, or you post your problem in the Piazza. Yeah. Okay. Yeah. Now let's go over the cover, right? The details about the cover. Actually, we have these in the Blackboard. You see, I opened the. We have 2 parts. One is for the assignment and the exams. One is in the material. I have all the videos of the classes. Right? You can check those for the coverage. And here we already have 3 exams, so they cover more details for cover. exam 1, exam, I have 3, right? I have 3 exams, exam 1, exam 2, exam 3, and then we have last part, the digital control. So the thing is, let me move these to the side. Here, covered. Those covered by exam, midterm exam 1, 2, and 3, and then the digital control. Yeah, actually 4 parts. The part covered by exam 1, by midterm exam 2, by exam 3, and this part we do not have exam, but we have homeworks, right? The problem will be something similar with the homeworks. Like you have, how many homeworks do we have? 1, 2, 3, 4, 5, 6. 6 homeworks. So for this part we will have problem some similar with some of the homeworks, right? In the sections or the chapters, there will be chapter, my problem only chapter 7. Actually we also have chapter 4 section, the last section. Photo 4, this one, photo 4. And chapter 7, chapter 8, sorry. 8 or 7. Oh, I put the wrong problem in the homework. Let me see. This is homework 9. No. It's here. Yeah. Chapter 8. Yeah, homework 11. Chapter 11. Homework 11. Chapter 4 and 8. 4 and 8. Yeah, one problem from chapter 4 and the other 3 from chapter 8. So this is chapter 8. And in chapter 8, we didn't finish all of it. We just studied the first few parts, the sections 1, 2, 3, just 1, 2, 3. Yeah, 1, 2, 3. 1, 2, 3, and 3 we really have here. 8.3.2. 8.3.2. Okay. Yeah, 8.3.2. So 0 or 0 introduction. 1 to 8.3.2. Right. 1.2.3.2, 8.3.2, 8.1 till 8.3.2. Okay, so this is for chapter 8, the covering. And the coverage. Okay. Then for material, actually you can go back to the previous exams, right? We have exam 1, 2, 3. I gave review for second and third exam, right? So you can go back to check those reviews, and also you check the first exam. Just the exam itself can give you the can show you which part it is really covered, what kind of topics. So here I only states a little bit about chapter about the digital control. The digital control. Digital control. For digital control, actually we only have two methods, right? Two methods, or two and a modified one. So we have method. We have the testing method. Right? Testing method. We have the match pole and zero method, and the MMPZ method. Yes, three methods. I think I introduced one more, but in the homework problems we only have these three. Yeah, you should know how to do it. Of course, all of them you can find the MATLAB code to run it, right? Like you have G of S equal to something, then you can run in MATLAB. But I suppose you can calculate, not by MATLAB. And there will be, we have GD of Z will equal to G replace S by 2 over T Z minus 1 Z plus 1. Right? This is the testing method. This will equal to something. You just plug in this part in GS, replace all of the S by this part. Then you get your result. And you can use MATLAB to verify, to make sure you give the right answer. Can use MATLAB to verify. Just verify, not the work yourself. You still need to work on it. All right. And similar for the MPZ method, match the PZ method. This one already pole or zero. You should have this term, right, as a factor of the in the numerator or denominator. This one will go to Z minus E to the negative AT, just like this, like this. And also in numerator, sum Z plus 1 in numerator. Yeah. Sum of these in numerator. Right. How many? Depending on order. You will make the final result in both numerator and denominator. They should have same order. Then that is the MPZ method. This way, in this method, the modified MPZ method, the numerator can one order less than denominator, right? But if the system itself is already with the same order in numerator and denominator, the same order, then you do not need to add any Z plus 1 in both MPZ or MMPZ method. So that means in that case, these two methods give you the same answer, right? Yeah, that's it. Quite simple. All right. Then you will say, okay, today we'll review what? Just like this? Yeah, so you here just check previous reviews. All right. Okay, here other than this, I gave you a, still review. I put everything together. All right. Review. Everything together. So what did we learn from this course the whole semester? So we have several parts. The first part, we needed some math tools. Math tools. The first one is the Laplace transform. Right? Yeah, that's almost the only thing we need, math tools. Then we need let me see, Do we need something else? Yeah, we need some like algebra, some linear algebra, some matrix. Yeah, but those is not. We cannot say they are some special like this. Like this is very. You have a system of tools. We have tables. We have definition. We have tables. We need a partial fraction. We have the final values, right? Always in the tables. Yeah, something like that. We have the whole thing. This is math tools. And another one might be used a lot is e to the j a equal to cosine of a plus j sine of a. A could be various things like a t or like omega t or something. Yeah. So this formula, Euler formula, is a Euler formula. Yeah, we need the Laplace transform, and also we use Euler formula a lot. And also you should know how to calculate determinant of a matrix A, determinant of a matrix Si minus A, the inverse of Si minus A. Yeah, you need to calculate. You should know how to calculate this kind of thing. Yeah, and also just A inverse or P inverse, right? Things like that. Okay. Then second thing about the system itself. Now we have several things. The first one is a differential equation. Differential equation and then we need a transfer function. Okay, this equation is about the input and output, right? Input and output. And then we need state equations. This is in matrix form. Right? We have two ways to describe system, and we have some change in the transfer domain. So we have transfer function. And then we have structure. This is in a graph way, right? You give a structure, You have a block diagram and signal flow. We have both, or I just introduce one. Anyway, this is structure, right? Structures. So we have these four types, and we need to know how to change between them. So you know differential equation, you should know how to find the transfer function, right? How to find the transfer function, and go back. If you know the transfer function, can you give the differential equations? And then from transfer function or the differential equation from these two, can you find the state equation, the matrix form. And here we have CCF, we have OCF, we have MCF. We have different way to realize it, right? Actually, more than this, you can have any kind of matrix way, and so on. Actually, I put some other ways, but they are not canonical form. Right? Yeah. And then, if you have the state equation, can you have the transfer function? Can you have a transfer function? And okay, when you have the transfer function, of course, you can find the differential equation. Right? What else? Okay, so this is between different kind of way to describe it. And the structure for from structure, can you find the transfer function? That is 3. Can you find these? And also, can you give the state equations in matrix way? Right. So we need these kind of things. And we have something more. We have different form, right? Different form. Here, okay, here I just say A, B, C, D. I mean anyone, any kind. Then we need a change between the. I just put here, yeah, switch each other. Switch from one to one, switch each other. If you know OCF, can you find CCF? You know CCF, can you find like MCF? And for anyone, can you find OCF or CCF or even MCF? How to do it, right? Yeah. So these are about the system, how to describe the system. And then, of course, for system, you should know how to find output from input. This one related with the way to describe the system. If you have differential equation, how to find output. You have transfer function, how to find output. If you have state equation, how to find the output. Yeah, in a different way. So I say 1, 2, 3, find output. They are in different way. I just write here, but you should know if you have the state equation, you have the matrix form to how to get the output if input is given. All the case we have formulas. Okay. Then, okay, so far here they are kind of it's a description about the system input output, right? We just describe them in a math way. Then we have the control. So the control design. Here we have several things. The control design, we say it's a goal of the control. Okay, goal of the design. The goals. We will consider the stability. Right, stability. We consider the tracking problem, tracking and the related type of a system, and the regulation or the noise cancellation and the related type of the system, right? And we have the sensitivity, of the system, and we also have some values, some special values, some specifications. Like the maximal overshoot, you can in value or in the value or in percentage, right? Yeah, you want your system satisfying certain requirement on the maximum overshoot and the peak time. Right. And the steady state. Actually, this is a part of this one, right? Part of the tracking problem. Steady state is the values. What else do we have? We have a lot, I think. We have the times, like we have the setting time, like a 1% setting time. Actually, you can also consider like a 2% setting time, 5% setting time. Yeah, but in most cases here in this, we just discuss this way. If you change this percentage, you can work in the same way, right? Setting time. and rise time, delay time. What else do we have? And the peak value, the resonant peak, right? Resonant peak and resonant frequency. Right? And the bandwidth. Right? We have all of these. So when you design system, you will try to find the system satisfy your requirement. The requirement will be one of them, like make the system have a tracking type 3, or like make a system with static arrow and steady state arrow, like make a system with a regulation type is some like a type 2. The steady state arrow in the cancellation of noise is like 1% is 0.01, or like you want a system with a maximum overshoot is certain value, and while your setting time is certain value, or the resonant peak is some kind of value, and the bandwidth is some value, So when you design, you want to find the system satisfy some requirement on this kind of goals, we say, topics, goals, your requirement, right? Yeah. Okay. So this is a control design, the topic. So what kind of the problem? What kind of things do you want to do? And then the 5 still control design, but now it's a method. This is goals, this is method. We have several methods. First of all, in most cases we're working on the feedback control. In most cases we work on a feedback control, feedback system. So you want design, right? You want to do something. You need to work on some system. Okay, what is system? It's a feedback system. So this things look like this. You have a part here, you have a part here, and you have a part here, plus, minus, and maybe sometimes you have one more part here. This is a plant. Then these 3 parts, not always we have all of them. In most cases we only have these. This is most common case. The most common used case is here. We try to find some controller here, and this one and this one, they are just they're just as one. Okay. But depends. Like in the rule lockers, I will explain later. In rule lockers, then here will be K. Here is 1, right? That depends. And this case, we think I think which part we have this. Can you remember? Yeah, we have some discussion about the steady state for the matrix form the system, right? In matrix system, and we have something here, right? Yeah, I don't have. Do I have homework about it? Maybe no. But in the class, in the lecture, I give an example. We have this, but in most cases, we only have this part. This part, like this is edge of S. So most part we have these two. We have this one, or both. Yeah. So we work on this, and then we say the design method or design tools. So we have several things. One is the rule lockers. ruler curves, right? You draw a graph. So here you should know how to draw. Not just sketch. Not you don't need to give the very details, right? You know how to sketch it, and you can also use MATLAB. That will be easy, right? And then you need to understand it. You know how to find some information about some information on it. Yeah. So you understand, right? The curve. What it means curve. In the ruler curve, every point actually it is a pole of the closed loop system, and with certain k, right? Ruler curve, it works like you have plant here, and the feedback k is here. Right? It's a closed loop like this, or this one will be same. This one will be same. These two, they have same ruler curves. In MATLAB, we have this one. In textbook, sometimes this one, sometimes this one. In textbook, we have both. In MATLAB, we just have this. Right? This is ruler curve method. This one is work on the poles. Alright. This is ruler curve. And we have another way to work on the poles. It's that one is earlier than ruler curve. I put here rules table for stability. Right? This is also work on the tools, on the poles. You use this one to check whether do you have poles in the right half plane, right? Okay. And then we have another one. We have Nyquist plot. Right, Nyquist plot. It's also work on poles, right? Work on the poles, all the poles. And we have another plot, right? Bold plot. Bold plot is in working the frequency domain, but it's also related with poles. Actually, poles are the kind of like the key of the control. Okay. Bold plot of frequency response. It's bold plot. Then we can use, out of them, we can do something. Like use the rules table, we can find the range of k to make a feedback system to be stable, or make just a system with some parameter in the denominator, say k, right? You can know, okay, which kind of value of k can make the whole system to be stable, right? We can use this method. We can also use ruler curves, right? And also you can use Nyquist plot. We have Nyquist. We have a criterion for the stability, right? We have which one? We have n equal to p plus z. Oh, I forget which one plus which one. We have three numbers. One is how many? Or maybe here here's n. Here's a p. I forget notation. The things like this. The pole is an unstable pole. Unstable poles of the whole system, or of TS. Okay, TS means the whole system. There will be this n. There will be this place. Maybe notation is p or n. I forgot. And the z is also unstable poles of the plant, g of s, right? Of g of s. And here's the number, how many turns of the Nyquist plot across the -1 point. How many turns? Or maybe this is n. This is p. Yeah, textbook here. Sorry. Check. Nyquist. I need to go to chapter 7. Okay, can you check it by yourself? Yeah, I'm not so sure the notation. I know the meaning. Here's a these two numbers do summation. One number is how many turns of the Nyquist plot go around the -1 point, and this one is the number of the unstable poles of the plant. And then the summation of these two will be the unstable poles of the whole closed loop system. Then you know whether the closed loop is stable or not. Yeah. Okay. Alright, these are the methods to design. And also, all of these, they are working in the transfer function or just a single equation, differential equation. For matrix form, we have matrix form. For matrix form, for system in matrix form, we also have tools. We can assign poles to K or L. So for K, this is a feedback design. We can design the feedback gain. And this one is for S meter. Okay. This is a matrix form. You should know how to select the K or L. Sorry, I need to go back to K. Yeah. Then for matrix form, when the system is described by matrix form, you should know how to assign poles for feedback or S meter. Okay, so what is the feedback right now? This feedback is similar with this case, but now the feedback is from the state. So we call this a full state feedback. The feedback will be like this is the plant will be x dot equal to ax plus b, and y equal to cx plus du. Here's the output is y, input is a u, and feedback. Now the feedback is not from y, it's from x. Then you have a k. Here's a okay, I use negative here. Negative k, then here I don't need to put minus. Then some r here. You think r is the overall input, y is the overall output, and u is the input to the plant, and x is the state of the plant. We use feedback like this, right? And for estimator, you need you have a plant, you have y, and this side is a u, and you use u and y together. Okay, how to give? Okay, I say this one. It's estimator. The estimator will give you x hat, which will be a estimate of the state variables inside the plant. Suppose the plant is you cannot look inside, so you will use this estimator to estimate the value of the plant, and then you can have a feedback if you want. You can have a feedback based on this x, similar like this. You put a negative k here. This is r. This is the overall. This is a feed. Now this is a feedback from y, right? Y go back, then you have some x hat, and then go back. So this one and this one, these two are similar. These two are similar. So this is 1, this is 2, this is 3, this is 4. Then 1 and 3, 1 and 4. Writing this way means similar. Okay, similar. These two are similar, but this is in the transfer function form, and this is in matrix form. And the benefit of this one, actually, we can extend these to MIMO system very easy. Yeah, when we discussed just in the first dimensional case, right? We only discussed single input, single output. But you can change this to be MIMO very easy. Formula is totally same. You just change the size of the matrix, then you have high order case. Yeah, so this is a convenience in complex cases, more complex cases. And this one only work for single input, single output case. Yeah. Okay, so yeah, roughly speaking, the whole semester we just learned these kind of things, right? We have five part. Yeah, let's go back. 5 part. First one is math tool, then how to describe the system, then how to find input output. Actually, these two you can think both are just related with system. You have a system, try to understand the system, try to describe the system, right? Yeah. And then we will design. Design, we have 2 parts. Actually, both are same thing. Both are part of the control design. The first part is the goals of the control. So you want control, you want design. So what's your aim? What's your requirement, right? So we have this part. We have different topic, different requirement. Then all these requirements, they are described by some math tools, math formulas, or some values. Okay. And then we will select our controller or our system to satisfy the requirement. Then what kind of method do we have? Here we introduce several. The first few is a Ruhl-Lacker's way, the rules table, or Nyquist plot, or both plot. Out of these, they are working for the single input, single output, and the system is described by a transfer function or a differential equation. And here we have 2 more methods. They are working for the matrix form. I lost something. Oh, no, it's fine. Yeah. And then of course we have the digital control part, right? As I mentioned here, this is digital control part. As a design, actually this design is based on the analog way. So all of these are working in the analog way, right? So we can design the system by the analog way to design it. After we finish it, if you want the digital one, then you, based on these analog controllers, you can transfer it to a digital controller. Then we have here I introduced 3 methods to transfer the analog system, analog controller, to be a discrete time system, discrete time digital controller. Okay. Yeah, that's all for the whole class. I would say this class is not difficult. Yeah, the idea is, as I explained today, right? It's quite simple. It's easy to be understood. But in the calculation, we need a lot of math. A lot of like a matrix calculation, like some fraction, partial fraction, like it's not too complex, but a lot of calculation. So like during your exam, you need 2 things. One thing is understand the problem, understand how to do it, how to work on it, and the second thing is make sure all your calculation is correct. All right. anything else. Okay, that will be all for the review I want to give you here. And then in the class, after you watch this, you can go to the classroom. I will be in the classroom in the Zoom meeting. After I think now is 45 minutes. I suppose give you 45 minutes. I will be there. The class is 9:30. Okay, I start be there after 10. After 10, all right. So after 10, you can go to the Zoom meeting to find me for the class, and if you have any question, then we can discuss there. All right. Okay, and that's all for today. And then, okay, this is the 14th week, Wednesday, right? Then followed by holiday. After holiday that we review, that will be the 1 week for review. Then this final. Okay, so here I just wish you all have a great holiday. Have a happy Thanksgiving Day. All right, bye bye. That's all for today.